Hi, welcome to the breadboard. Have you ever wondered in industry why there are so many rules and regulations when it comes to dealing with electricity? Well, the simple answer is they don't want people getting killed or badly hurt, or even not badly hurt, but they don't want people getting electric shocks when they're working on panels and equipment and things. Part of that process involves having to get a multimeter, something like this Agilent, 1272A or equivalent. It could be a Fluke, could be somebody else's. That's got suitable cat rating for the environment that you're using it in. So this one is rated up to cat 4, well, cat 3. So it can go up to about 1,000 volts with the appropriate probes on. Not all probes work to cat 4 or cat 3. And then on top of that, you have to verify or validate, more specifically, there's a whole process for it, that your multimeter is reading properly before you do the test on the equipment. Then you got to go to the equipment, do the test, and you're typically looking for 0 volts to be present. And then you're going back to validate your meter again to make sure it's still functioning properly. And that's all before you can even start working on the cabinet or whatever piece of equipment it is that you're needing to do maintenance or installations or whatever on. Now, on top of that, there could be 3-phase involved and things too, where you have to repeat that for each of the phases. So it can be quite time consuming. And if you're in an environment where you're having to do this a lot, that's a lot of time that you can spend just making sure things are safe to work on. Now, it's important, don't get me wrong, but it's one of those areas where a lot of people get tempted to cut corners. So in order to battle that, a company called Panduit has come out with a device that you can install in the panel that can give you an indication on whether the panel is powered down or not, and it can significantly reduce the amount of time it takes to do these tests. So we're going to have a look at this now. I'm going to bring the camera up close and we'll have a look on the bench first. Now, and then we will start feeding it some signals, and we'll have a look at some of the safety things that are built into it. Maybe take the lid off it if it's easy to get into, and have a look what's inside it as well. But one of the things that this device will do is within a matter of seconds, it will tell you whether the power is removed from up to 3 phases. And it'll do this, and it uses a whole bunch of redundancy techniques in its design in order to make sure that it is, giving you the correct information. And that includes having multiple connections to the phases, having an internal check before it does the wiring check, etc., etc. And it will also work on AC or DC. So, even if you're not working on a mains or high voltage AC system, you could be working on a DC system that's maybe used for copper plating or some other process where you might have hundreds of amps at, say, 50 or 100 volts or something, the kind of area that most people think, oh, you can touch that and it won't hurt you. But you can still cause a lot of damage or injury if you're not careful. So this will handle both the AC or the DC. So anyway, let's get in close and have a look. Okay, so here we are up close to the box. Didn't bother showing you it coming out of the packaging that it came shipped in, but suffice to say it was well wrapped. Now, first thing you notice is it contains a lithium battery. You'll see that this is an important thing to remember in a minute. I've already had a quick look inside, kind of had a sneak peek, you might say. But anyway, let's get this open and have a look what we've got. Okay, instructions. So this is the Panduit Verisafe AVT, absence of voltage tester. Now just remember that it's testing for the absence of voltage, not the inclusion of voltage, although it does detect that as well. Got a, well, it looks like a network connector, but it's actually not. It's just a remote connection for the front panel control to the main unit in the back. We've got a lithium battery in here. I don't think it's rechargeable. 3.6 volt lithium battery. AA format, not to be confused with a 1.5 volt AA battery. A bunch of stickers for setting up your panel in the local language that's important for you. It looks like there's some for the actual testing unit and some just to stick on the case. So in the box we've got the my shipping information. Don't need to look at that. So we have the actual testing unit with a whole bunch of pre-wired leads. This is the Verisafe model number VSAVT-CO2L10. I don't know what other models there are, but this one is designed for one DIN rail mounting. You can see here it would sit like that on a DIN rail. Pre-wired for measuring up to 3 phases. Now the instructions we'll have a look at, but you can handle a lot of different configurations, whether it's star, delta, 2-phase, 3-phase, single phase, etc. On this. We have the only visible connection we have on this is the RJ45 connection here, which will hook up with that cable we just had a look at. Looks like you can also just simply screw this to a panel. There's 4 holes around the outside that would allow for that. And the only other thing in the box looks like the front panel indicator for the unit. So you've got a big yellow warning sign, right? Green light indicates de-energized. Right, Verisafe absence of voltage tester. So there's a button on here, and then there are a bunch of lights. Now there's no battery in here, and it's not hooked up to anything right now, so it's not going to show us anything. So let's just pull all this out, get rid of the packaging out of the way, and we'll hook it all up and have a look at a few of the features a little more closer, and then we'll start giving it some signals and see how it behaves. Okay, that's everything out of the box. So first thing to notice with the front panel, you'd have to normally drill or knock out an inch, looks like about an inch or an inch and a half hole to push the panel in, push this mount into. It's also keyed so that it wouldn't twist once it's installed correctly. Simple plastic screw to fix it with. The only thing on this connector is the RJ45 connection at the back. I can actually see the pins down here. So my first concern would be that if I've got this off to say change batteries, because you just twist and remove the front, okay, and take it off, and then you can actually pull this forward so that you can get to the battery compartment here. There's a connection at the back here. If I'm putting my fingers in here, am I connecting myself to hundreds of volts potentially? Because, if the battery's flat, you aren't able to test whether it's live or not, okay? Well, the one thing I noticed when I pulled that out is if you look at the very back in here, I don't know if you can see, but right now the connection for the RJ45 is, as you can see here, would be about there. So it's just past this little black connection that locks in the connector here. When I pull forward the battery compartment, I noticed that the RJ45 actually goes with it. I don't know if you can see that in there or not. I'll try and take some pictures or zoom in on that to show you, but it moves right out of the way, which means that when you're putting the battery in, you've probably got a good 2 inches of space between any connections on this cable and anything you might get your fingers in contact with on this front. It's rubber O-ring sealed, so when it's all screwed back up again, it's going to be dust proof, pretty much environmentally sealed from anything that might be out in the workshop kind of area where this is going to be installed. So let's stick the battery in here. And it just plugs right back in again, and the front just screws on there, and the back unit just clips in like that. So there is nothing else you need to do. Now, even without all of this plugged in, right, it won't work yet because you're not plugged into this back unit. Once I plug into the back unit, so we just plug that into here, we should actually be able to start having something come to life. So we push the button again, and we still got nothing. Maybe I don't have this far in enough. Oh, there we go. Didn't have the back cable in far enough. So you can see there you've got the orange light come on, and it's gone off. So that's now all powered up, ready to go. So if I have nothing connected on these cables and I just simply push this, because it can't sense what's going on, because none of the cable ends are connected, it's warning me that there could be volts present. There's no red lights to say that there is volts, but there's no green ones to say that there isn't either. So it's warning me that this thing has detected that it's not wired up properly. Now, if we look in the manual here, we'll go through this a second. So it's, first thing at the front, follow the manual, risk of injury. It's very, very true. Very clear in nice English. First thing I mentioned about the battery, it's a standard AA size battery, but it is not a regular alkaline AA battery. So putting in a 1.5 volt battery will not work for this unit. You need to put in the lithium one at 3.7 volts so that it will work properly. So bear that in mind. Flipping through here, lots of warnings in, we've got French as well by the look of it. We've got a redundant monitoring output on this panel. So if we go back to here, we've got the lights on the front here, obviously, which will tell us the status of things. There's also a couple of connections on here, the double pair of relays. Now you could run them to two different things if you wanted to. The way that the book is recommending to do this is in a very redundant mode where you go into one, loop the output of the first one into the second one, and then out from that one off to whatever you're going to be connecting this to. Now it could be a PLC, it could be just an indicator light, it could be a lockout, whatever you want to connect this relay to monitor or manage something, you can do that. But they're recommending that you do it in a redundant manner because this is all about safety, right? So that's the relay contacts that are in there, and they're good for, does it say? Contacts are rated for 30 volts AC or DC at about 80 milliamps. So they're not big contacts or anything like that for switching any big loads, but they'll certainly be able to drive LED indicators or the input to a PLC or something like that. The wiring is all heavy-duty sense wires. You've got a pair of each color. So there's 2 yellow, 2 orange, 2 brown, and 2 grounds. So again, going through, and I'll put a relevant screen captures of anything. If I can find a PDF for this, I'll link to it in the description as well. So works from 0 degrees C to 60, so 32F to, so it's not really good for negative temperatures. I think part of that's probably due to the battery, but aside from that, in most industrial environments are not going to be going negative. And we've got the mounting options, like I said, on DIN rail, or you can mount it with the 4 holes that were around the side. The hole that you need to drill is, where is it? 1.2 inches, so 30.5 millimeters. And then you've got a little 2 millimeter knockout on the edge, top notch, to prevent it from turning. So what we've got here are a number of different wiring options, and as you can see, each of these wires go to separate phases. So you've got L1, L2, L3 in a delta configuration. You've got the star configuration. We've got 3-phase with no neutral, protected earth. So in all cases, the ground wires are going to ground. We've got 3-phase high resistance ground, plus neutral and protective earth. And then more of importance to me here in North America is we've got single phase with protected earth. It's single phase 2 wire. That's pretty much what we have in North America here. We've got the live and neutral, and we have the ground, of course. So what they're doing is they're connecting the brown to live, the orange to the neutral, and then the yellow ones are going to the ground, and then you've got the separate ground wires going to the other ground. What we also have in North America, and most households actually have this provided to the house, is they're calling it here single phase 3-wire, but it's kind of like a 2-wire. It's 2 phases. They have a transformer out in the street, and then you've got a center tap going to ground, and each side of it being fed into the house. So when you have your junction box, every other contactor, every other fuse breaker is connected to a separate phase. So if you go across the phases, you can actually get 220 volts, and if you go to a single phase in neutral, you get the 110. So this is able to handle that as well. The main thing it's trying to do in all cases is to make sure that relative to ground, there are no voltages on the neutral, live 1 or live 2, or live 1, live 2, live 3, or whatever they want to call them, depending on your wiring situation. So now we've got a corner, back to 3-phase again. We've got different configurations of those. So it handles all of them. And what I would suggest is you go through the manual. I'm not going to be able to test all of them. And I'm just going to test the ones that I can test here, which would be the standard household wiring and also the DC testing as well. And the bottom one here shows you can have 2 DC connections and a ground, but I would imagine it can also handle 3 separate DC voltages as well. So we'll do a little bit of experimenting to see how low it will go before it says things are safe. It does tell us in here how low it's supposed to go. Where was it? I saw it here a minute ago. Absence of voltage threshold is 3 volts. So anything below 3, it determines that it's safe. Anything above 3 volts should start showing up as having a red light and that it's not off. A few more warnings on considerations for installations. So use of overcurrent protection. Installing of an AVT with overcurrent protection is neither required nor recommended. When testing for absence of a signal, it is important to ensure that the tester is in direct contact with the circuit test points. Okay. A few instructions on how to wire it up. Now, one of the important things here is this diagram here. If you remember, I said that each phase on the tester has 2 wires. You should not connect them both together and put them into one termination point. Now, I may do that just for the testing because I don't have as many places to actually be able to do this in a real world scenario. But the reason for doing the 2 separate connections is to make sure that if the first connection falls out, the second one is still connected securely. If you've got them both on one terminal, if that terminal comes loose and the wire drops out, it may think that things are okay and working properly, but reality is they're not. The chances of both these wires coming out on the wire is very, very slim. Secondly, the sensing wires do actually sense between themselves to make sure that it does have continuity between the 2 sensors of each of the same color as well. And the benefit of that is it makes sure that it is also measuring that the wire is intact that it's connected to as well. So it's actually lots of belts and braces and things. Here's just a picture of it showing mounted with DIN rail, adding the stickers. And I think that's pretty much it. And then an extensive commissioning checklist, which includes testing the system to be powered off in the old-fashioned way before you go and start wiring the new tester into the system. Remember what I said? Test your multimeter, go do the circuit under test, and then retest your multimeter to make sure it's still working before you decide that that circuit that is under test has actually been truly turned off. Many times where you might test your multimeter, go to the, then you go travel to the place of work only to find that your multimeter got banged, bashed, your wire broke or something, and you think it's safe and it's not. A few troubleshooting tips for wiring and warnings and things. So battery voltage low, replace it. So if you don't get any indicators, you replace the battery. Voltage detected above the threshold, you're going to get the red lights. When you turn it off, wait several minutes for any stored energy to dissipate. Proper installation of the sensor leads could not be verified. That will probably also flash the yellow light indicating hardware failure. And of course, back to the fact that you need to replace this with a 3.6 volt lithium battery, AA sized. And that's pretty much it. A little bit of information on replacing the O-ring and the Panduit warranty, and that's everything in the manual. It's actually fairly comprehensive for something that I think to all intents and purposes is pretty simple in its, especially to talk about, not so simple at what it's probably doing inside this box. And we will, it looks like there's just 1, 2, 3, 4 screws, so it looks like we will be able to have a look inside here. So let's just, I'm going to strip these wires back a little bit, and what I'll do is I'll connect each of the colors together. What that should do is actually allow us to get a green light, because it would think that there's no voltages, I think, unless they're floating and it thinks that there is indeterminate voltages, because normally when it's connected to a system there would be some kind of load that might bring all of these together. Anyway, we'll find out in a moment.